Hello, lesson 2 on standard 1. Today we are going to, on the last lesson we took equations, x and y equations, and they're linear equations. They were both to the first power, and we graphed them. What we're going to be doing today is taking equations and actually solving them. Now, basically solving an equation for a letter, there's going to be one letter in the equation. You have to find out what it equals. Okay, it's like solving a piece of a puzzle. I have kind of a system I like to use to go about this. Some of you might not like it. I think it helps, but it pretty much is a surefire way to get through. Now, if you remember, in Algebra 1, at the end of Algebra 1, we did like equations where you'd have 2 and 3 answers. But today we're going back to just one answer because the variable is only to the first power. So there's only one possible answer because anytime we solve equations, we're going to know how many answers, and there's only one possible answer to all of these. So I have some number x that if I take away 4, I end up with negative 16. Okay, I need to find out what that number x is that I started with. So first off, know where your variables are at and what the coefficient is. So here's my variable here, x. It doesn't have a coefficient, so that means its coefficient's automatically 1. Okay, 1 times x. Okay, if they have parentheses, you're going to use your distributed property rainbows, but we don't have that here. So if there are multiple variables, no, there's only one, so we don't care about that. Now undo the adding and subtracting. So what I like to do is kind of circle that 1x and just block that off, and I need to undo the minus 16. So I'm going to add the minus 4. So I'm going to add 4, and I have 1x, and then I have the equals because those canceled out, and then negative 16 plus 4 is negative 12. Now, it says divide by the multiplying coefficient. Well, I don't need to divide by 1 because it's just going to be the identity property of multiplication. So I know that that answer is negative 12, and I essentially have that. Okay, next one. Negative x divided by 10 equals 4. Okay, know where your variables are at and what the coefficient is. Now, this x, again, it's going to have a coefficient of 1, but it's more than just negative 1. It's actually negative 1/10 is the coefficient, okay, is how that's going to work right there. Okay, if you have parentheses, no, that's not a problem. There are multiple variables, no, that's not a problem either. Undo any adding or subtracting. So I'm going to circle this, and there's really no adding and subtracting to undo here, okay? Now, here's the key part. Divide by the multiplying coefficient. Well, first we need to get rid of this 10 here, okay? So what I'm going to do the opposite of dividing by 10, which is multiply by 10. Now, I'm going to want to divide by negative 1, but first we have to deal with the 10. Okay, it's not like this one where there was no denominator. Okay, so once we get down to this step, we're just going to multiply 10 to the other side. Okay, that's how I like to do it. So what's 4 times 10? It's 40. So negative 1 times x equals 40. Now we can go ahead and divide by the negative 1. So divide by negative 1, divide by negative 1, and x is negative 40. Okay? So you can't let that spook you if it's a fraction as your coefficient. Okay? You're going to multiply by the bottom. Just scribble it out, multiply at the other side, then you'll be ready to divide. Okay? Know where your variable's at and what the coefficient is. Coefficient's negative 3. I like to kind of put a dot right there. That's just I've kind of grown to like that, so I know it's negative 3 times x. Okay, there are no parentheses. If there are multiple variables, no, there's only one variable. Undo adding and subtracting. Yeah, I'm going to circle that, and I don't really have any of that to undo. Okay. Now I divide by the multiplying coefficient. Okay, so I divide by negative 3, and those cancel, and divide by negative 3. Okay. So x is negative 9. And I'm going to add something to this. Undo adding and subtracting after circling the variable and coefficient. Okay, now, next one. Letters Y, so I'm going to put Y equals instead of X. Not a big deal. Now, know where your variables are at and what the coefficients. That's a Y with a coefficient of 6. That's a Y with a coefficient of 1, so we're going to put that there. So I have a 6Y and a 1Y right now. But we do have a parenthesis, so we need to use our distributed property rainbows. So, and the reason why you have to do that, because you can't really take 1y minus 3. They're not like terms. The 1 has a y and the 3 does not have a letter. So the next best thing is to take this multiplier outside and multiply by this quantity. The 3 belongs to multiplied by everything in here. So it's a dp rainbows. I like to put dp. Okay, dp. And what I have is I have my negative 27 plus my 6y, my equation, and now I come to my distributed property rainbows. I take 3 times 1y, that's 3y. Now when I'm doing the dp, the distributed property, if I have subtraction, what I like to do is make that addition and then a negative afterwards. So I know that I can make a plus here, and then I take 3 times negative 3. 3 times negative 3 is negative 9. Okay. So that is how you deal with your parentheses. And we've done that before. Okay, if there are multiple variables, collect like terms. Now, we have multiple variables, a positive 6y and a positive 3y. Now, what we're going to do with those depends on where they're located. Now, if they're located on the same side of the equation, we're going to make a little adding pyramid that tells me, okay, I can just add those together and make it into one variable term. But if they're on opposite sides, we have to balance the equation. It looks to me like they're on opposite sides. So balance, I like to get rid of the 1 on the right. That's just me. Okay, so minus 3y. Minus 3y. That's what balance means. You just get rid of the variable on that side, and what you do to one side, you have to do to the other. Okay, so I have negative 27, and then positive 6 minus 3 is positive 3y. And then negative 9. Okay. Now I'm going to undo the adding and subtracting after circling the variable and the coefficient. So I'm going to circle that 3y. And we have this negative 27 we're going to have to undo through adding and subtracting. Well, it's a negative. It's like a negative would be like a minus, so I would add it to get rid of it. Plus 27 plus 27. And then I have 3y equals 18, and then we're going to divide both sides by 3, and 18 divided by 3 is 6, so y equals 6. So that one was a little bit tougher. Okay, next one we're solving for x here. Okay, know where your variables are at and what the coefficient is. There's my x, and the coefficient's 1. If you have parentheses, use your distributed property. Okay, we have that. And I can't add 1x to 4, so I need to make my distributed property rainbows. So I have to multiply the 2 belongs to everything in here. Okay? So 2 times 1x is 2x. And I already have a plus sign, so I don't have to worry about the plus negative like I did on the last problem. That's 8. That's gone. And then we're equal to 8. Okay, are there multiple variables? Nope, just one, so I'm good. Okay, undo the adding, subtracting after circling the variable. So here's my x, and it's coefficient of 2. So I'm going to undo the plus 8 by minusing 8, and 2x equals 0. And we're going to divide by the multiplying coefficient. There's no fraction, so we're just going to divide by the 2. And that's 0, okay? So I got an answer for the 0. Okay, my next problem. X equals. Know where your variables are at and what the coefficient is. So here's my x. It's got a coefficient of 1. If you have parentheses, use the distributed property rainbows. Okay. Looks to me like I definitely have parentheses. So the 5 needs to be multiplied to everything in there. And 5 times 2 is 10. Now make that minus plus negative so you can just write plus. I always like to write plus out of the distributed property. Easier for me to know my signs. 5 times negative 1 is negative 5, and that's going to have x connected to it. That's gone. Then we have the equals and then 0. Okay, if there are multiple variables, nope, there's just one. Okay. Undo the adding and subtracting after circling the variable and coefficient. Yep, we have to get rid of this 10 here. It's like a positive 10, so we'd subtract it. It's like a plus 10 we're getting rid of. Okay, so I have negative 5x equals, and then 0 minus 10 is negative 10. Okay, now divide by the multiplying coefficient of negative 5. That's kind of always your last step. And if it's 1, you don't. If it's positive 1, you don't need to divide. But anything else, yeah, that's kind of the last step. Negative 10 divided by negative 5 is positive 2. Okay, next. 5x minus 9 equals 8 minus 2x. Okay, know where your variables are at and what the coefficients are. There's an x that has a coefficient of 5, and there's another x that has a coefficient of negative 2. I know it says minus 2, but that minus 2 means it would be plus negative. You can either put plus negative if you want, or if you know that it's a minus, that's cool too. If you have parentheses, use distributed. No, that's not a problem here. If there are multiple variables, collect like terms. Now, there's definitely multiple variables, so we have to pay attention to if they're on the same side or the opposite sides. Well, it looks to me like the 5x and the negative 2x are on opposite sides, so we need to balance the equation. So again, I'm going to pick this term over here and just get rid of it. So if it's a negative 2, to cancel that, you're going to need to add 2. Add 2x. Okay, 5x plus 2x is 7x minus 9 equals 18. Okay, now undo the adding and subtracting after circling the variable and coefficient right there. So we have a minus 9 to undo. So plus 9 plus 9. 7x equals, this is going to be definitely a messy answer, 27. And 27 doesn't divide by 7 evenly, so you can either round to the nearest hundredth on your calculator. I don't have a calculator on me right now. Or you can just leave it in proper 27 over 7. If you're really ambitious, you can do the mixed number, which would be 3 6/7. It's real close to 4, but so forth. That's good enough. Okay, next one. 6x minus 12 plus 2x equals 3 plus 8x minus 15. Wow. Okay, there's a reason I put that there. Know where your variables are at and what the coefficient is. Okay, I've got a 6x here, I've got a 2x here, and I've got an 8x here. So we have 3 variable terms. There are no parentheses, fortunately. That's good. Okay, if there's multiple variables, you need to collect like terms. Well, we definitely have multiple variables. We said just know there's 3, okay? So the ones that are on the same side, we're going to make a little adding pyramid here. So these two right here, I like to do this little pyramid here and write the word add, okay? So 6x plus 2x is 8x, okay? And we can cross them. After they've been added, you can cross them out, and then we have the minus 12. Equals, and then we got the 8x. Actually, can't you combine the 3 and the negative 15? Yeah, you can do that, and that makes negative 12 plus your 8x. Okay. Okay, but the problem is there's still multiple variables, but now they're on opposite sides. Okay. Well, the deal is they're the exact same. So 8x and 8x can be canceled. Okay? Now, here's what you write when those variables cancel. Did you end up with the same number? The same number. Got to be the same number, same sign, same everything. Yes, you did. So that means this is what we called an identity equation. You can put ID. Now, if the numbers are different, you write NS, no solution. Okay, did you hear that? Numbers are the same, and the variable canceled out. That means it's an identity property. That means any number, x can be any number, and this side of the equation will be equal to this side. I mean, x could be a million. I could put a million in for x here, a million there, a million there, and these two sides are going to be equal. Okay? I could put a 2.7 there, a 2.7 there, 2.7 there, do the math on each side, and the two equations would end up the same. Okay. Now, if they don't end up the same, that's a no solution. That means there's no number where they end up the same. It doesn't exist. Okay, let's keep going through here. Okay, know where your variables are at and what the coefficient is. So we got a 2x here. Got a 7x here, and it's going to be a 1x here. So again, there's 3. But unfortunately here we have some distributed property rainbows we're going to need. So again, I'm going to draw this 3 from here, and this here. And those means dp. The distributive property is what those rainbows are actually called. Now in Algebra 2, you're going to see me get more specific with the terminology. Okay, Algebra 1 is just teaching you what to do. Now the terminology becomes key. Now remember whenever we're doing the distributive property, any minuses, and that includes the outside number, I want to make plus negatives. So here with the 3, and then I have a plus there, that's good. And then here with the 3. So now I'm ready to actually know what the heck I'm multiplying. So I have the 12, and now when I get to this negative 3, I don't want to write that, I need to multiply. Negative 3 times 2x would be negative 6x. And negative 3 times 1 is negative 3. Okay, and you can cross that out. And now you come to your equals. 7x isn't part of the distributed property, but the negative 3 is. So don't write that. You need to start multiplying. Negative 3 times 7 is negative 21. And negative 3 times positive 1 is negative 3, but it'd be negative 3x. Okay, so we got through that mess. And now keep going. There are multiple variables, you need to collect like terms. Okay, same side, you draw your adding pyramid. Opposite side, you balance. Well, let's do these ones that are on the same side here. Okay, I'm going to, again, connect them and just write add. Okay, so I've got, by the way, over here, I'm going to add this 12 and negative 3. So 9, 12 plus negative 3 equals 9. And then I have my negative 6x. And over here, I know I'm supposed to add the 7 and the negative 3, so that's 4x plus my negative 21. Okay. And the problem is, and there's still multiple variables, the negative 6x and the 4x, so we now have to deal with those. But now they're on opposite sides, so I'm not going to do the adding pyramid. Instead, I'm going to balance the equation. So I'm going to pick this 4x, get rid of it. So I've got 9. Negative 6 minus 4 is negative 10x. And then the equals. And then negative 21. Okay. All right, now that there's only one variable term, we're going to circle that along with its coefficient. And we have a 9 we need to undo. It's positive, so we're going to minus it. And I have negative 10x. And negative 21 minus 9 is negative 30. Think of it like, if you're not good with negatives and positives, think of it as a number line. If I'm at negative 21 over a number line, and when I subtract, I'm moving deeper into the negatives. Okay, and then it's time to divide. That's 3. Okay, and then the last one. Know where your variables are at. We got 5x and a 10x. Okay. If you have a parentheses, use your distributive property rainbows. So here, so it's going to be 10x plus 8 equals 10x plus 6. Okay. Okay, are there multiple variables? Yeah, there's a 10. Yeah, they are. And they're on opposite sides, so we want to balance the equation, but if they're the exact same, we are going to go ahead and just cancel them, because if I take a 10x away and a 10x away, then the x's just go away. Now this time we ended up with different values on each side, an 8 and a 6. Well, those aren't the same, so that is going to be an NS. That's no solution. Okay. And that's kind of the guidelines to basically solving an equation here. Okay, now we're going to look at some story problems that are kind of going to be new to you, and I'm actually going to go over actually your assignment. I don't want you working on it yet. It's just going to be this page, and then there's one on the back. I'm actually going to work through the story problems a little bit with you because we didn't really do this in Algebra 1. I think it's going to help in the long run, but it might be a little confusing at the beginning. Okay. And that pertains to time, distance, and speed, okay? Now, let's say a car, and this is just notes to kind of look at. Let's say a car goes 60 miles per hour, and then it travels for 3 hours. Every hour it's going 60 miles, okay? That's what that means. So what's the total distance? Well, if I'm going 60 miles every hour, and I'm going for 3 hours, I have 60, 60, and 60. It makes 180. Well, you could just multiply them. So the distance that we travel is equal to the speed times multiplied by the time. Okay? Don't say times time. That sounds weird. Speed multiplied by time. There's a formula. Now, let's say I have 200 miles to travel in 4 hours, and I want to know how fast I need to drive my car. Okay? Well, if I go 50 miles every hour, you're going to have 50, 50, 50, 50. That's 200. Okay? So I'd be there. Now, how would I get 50? Well, you divide 200 by 4. So the speed you need to travel is equal to the distance you need to travel divided by the time for which you need to travel. Okay, let's say 200 miles at 40 miles per hour. How much? And I can only go 40 miles per hour. Let's say I'm on a moped or something. How much time is that going to take me if the fastest I can go is 40, and I got to go 200 miles? Okay, well, it'd take 5 hours because 200 divided by 40 is 5. So the time is our distance divided by speed. So these three formulas are very important to know, okay? Now, when solving these problems with distance, with speed, with time, we're going to be making something new here. We're going to be making a table. There's going to be two things traveling, object 1 and object 2. And then what we do is we just put speed, time, distance, and then what I'm going to put above them is the formula. Okay, so speed I know is distance divided by time from up there. I know that the time is the distance divided by speed, and I know that the distance is the speed multiplied by time. Okay. All right, so let's look at this first problem. Two planes leave the airport at the same time. And they're going to go in the same direction. That's important, okay? One plane travels 600 miles per hour while the other plane travels 660 miles per hour. When will the planes be 1,200 miles apart? Okay? So we're talking distance, speed, and all that. So what I'm going to do is make that chart. I split it in half, and there should be 4 columns. The first one, they're planes, so we'll just write plane 1, plane 2. And then we're going to put speed. And I'm going to put above in parentheses d divided by t. Okay. And then I'm going to put time. I'm going to put above that's distance divided by speed. Remember, it's from here. And then I'm going to put the distance. That's going to be our speed, not divided though. It's going to be the speed multiplied by the time we travel. Okay. And yeah, there is a quick way to get the answer to this problem, but I just want to kind of get you comfortable with it, kind of an easy one. Okay, so what's the speed of one of the planes? Doesn't matter which one. Well, 600 miles per hour. The miles per hour is the rate. That's your speed. Okay. Okay, so I'm going to cross that out. And then the speed of the plane 2 is 660. What's the time it takes? You don't know that. It doesn't say that. It would tell you the number of hours, but we don't know the hours because that's the answer to the problem. It says when will the two planes be? So hours equals, and you can see that down there on the corner. So I don't know that, so I'm going to call this X, and I'm assuming they're traveling for the same amount of time. I just don't know what it is, so they'll both be X's. Okay. Now the distance, that would be just the miles. Well, you see 1,200 miles, but neither plane really traveled that for distance. That's just how far apart they are. So I'm not going to put it in, but what I'm going to put is I'm just going to put it kind of in the middle here. So you're like, well, what do you put here? Well, what is the distance? It's the speed multiplied by time. Where's the speed? 600. Here's the time, x. You can just put 600x there. Here's the speed, 660. Here's the time, x. Speed times time, 660x. Okay? Now you're ready to write the equation with these three items. Now, my first question, these planes are going in the same direction, but how many miles is this gaining on this every single hour? Well, 60. They're going in the same direction, but he's gaining 60 miles. So you get that by subtracting them. So you write 660x minus 600x equals 1200. And then it's easy. 60x equals 1200 divided by 60 divided by 60. You can use your calculator. I just don't have one handy. And that's 20 hours. Okay, now let's go to another one. You need to turn to where it says problem number. It's the very last problem. Okay, 2 buses leave Houston. 2 buses leave Houston at the same time and travel in opposite directions. One bus averages 55 miles per hour. The other bus averages 45 miles per hour. One of the buses be 400 miles apart. Now, some of you are like, this is just the same as the last problem. Yeah, but there's one major difference. And that's the fact that they're traveling in opposite directions, not the same direction. They're going, instead of the last problem where they're both going this way, but one's just gaining on the other. One's going this way, and one's going that way, okay? That leads to one little itty-bitty change, but not a big one. So let's make that 4 thing. Okay, bus 1, bus 2. Okay, and then, Hermson, you idiot, I didn't give myself enough room. Okay, I'll just write them down here, okay? So speed. And remember, you got to get used to it. It's distance divided by time. And you're like, well, this is a little confusing now. Yeah, you'll get better with it the more you practice, just like anything else, okay? Distance divided by speed. Distance is the speed multiplied by the time, okay? All right, so what's the speed of one of the buses? 55. What's the speed of the other one? 45. So those are your speeds. What's the time they travel? Again, what they does by time would be just the hours. They never tell us that. So, but they travel for the same time, so we can call both of them x. We don't need to differentiate. Okay, now distance is just the miles, not miles per hour, just some miles. And the only thing you know about that is when you want to know when they're 400 miles apart, but not really when nobody really went 400. So we're going to put 400 in the middle. Okay. So again, it's distance, speed multiplied by time. So the speed of this bus was 55. I don't know the time it traveled, so I can write that as 55x. And then what's 45 times x? 45x. Now here's where our main difference comes into play here. Okay. I do not think it's gaining. They're not moving 10 miles apart every hour because they're going in opposite directions. So let's say start in the same place. After 1 hour, one of them's at 55. That's what 55 miles per hour mean. And after 1 hour, the other's at 45. How far apart are they now? I don't think they're 10 miles apart. I think they're a lot more than that. I think they're probably like, 100 miles apart. Okay? So instead of, when they're going in opposite directions, instead of subtracting them, you're going to write an addition problem on that side with the x's. Okay, so that's 100x equals 400. And x equals 4. Okay. All right, now as you know, we have another story problem here. Okay. And we haven't really done this either, okay? There are two classes. One class has 19 more students than the other class. If there are 53 students in the two classes combined, how many students are in each class? Now, as you remember, now we're not dealing with a distance problem, so we're going to put this away. As you know, I like to identify units, but the problem is in this problem there's only one unit, okay? Students, that's the only important unit, okay? I mean, sometimes there's 2 units where we make that in the line. But when I'm only, and by the way, classes isn't an important unit because I know how many there are. There's 2 of them, okay? I don't need to define that with a variable. That'd be stupid, okay? It doesn't change. Just students. So when there's one variable, what are they being organized into? Classes. So I'm going to put class 1, class 2, and total. I'd put a class 3 if there were 3 of them, and then total. What's total number of students? 53, we know that. How many does one class have? You don't. By the way, you don't just put 19 in. There aren't 19 students in a class. There's 19 more. So if you remember from last year, when 2 things I don't know, but I know one's more than the other, we call one of them, it doesn't matter which one in this problem, x plus 19, and the other one's just x. Okay? Alright, so I can have my equation. X plus 19 plus the x from class 2 equals 53. Okay, and we can just add the x's together. It's 1x plus 1x because they're on the same side of the equation. So adding pyramid, that's 2x plus 19 equals 53. Okay, so I circle that. I'm going to minus 19 from both sides. So 2x equals, what is it, 34. That's pathetic. I didn't know that right away. And x is 17. So there's 17 students in class 1, and then in class 2, by the way, class 2 has 17. Class 1, you just add 19 onto it. Okay, so I'll put a little tiny plus 19, because you know that's your smaller class, and 19 more would be 36. So there's 17 and 36. Okay. All right, and then let's do 62. Okay, the first stage of a rocket burns 28 seconds longer than the second stage. If the total burning time for both stages is 252 seconds, how long does each stage burn? Again, the only significant unit is seconds. Okay? But there's 2 different rockets, so I'm going to put seconds for rocket 1. Seconds for rocket 2, and then the total seconds. So our total seconds is 252. Okay, we know that much. And then the only thing I know about the 2 rockets is that one's 8 seconds longer. Again, you can't just put 28 and call it good. You don't know them, but when one's 20, one of them's going to be x plus 28, and the other one's x, and it doesn't matter which one's which here. Okay, later it's going to, but not here. Okay, so I'm going to put equals and pretty much plus. I'll just do it like that. X's, I have multiple variable terms, but they're on the same side. So it's going to be the adding pyramid. And I'm going to put seconds down there. You already have that. So 1x plus 1x is 2x. Plus the 28 that's there equals 252. Okay. So circle your variable and coefficient, and then undo the adding. And that is going to be 224. Okay. Then when I go divide by 2, 224 divided by 2 is 112. Okay. So the first one burnt for 112 seconds, and then you know that the other one was just 28 longer. Your first answer is just the x, and the other one's the plus 28 with the x. So plus 28 on that, and that is going to be 140. Okay. All right, that's all I got to say on that.